Lesson 8, Advanced Integration Techniques, Properties of Definite Integrals, Part 2. Right, we have to prove that the integral of fx dx between a and minus a is equal to the integral of fx plus f of minus x dx between a and 0. Now, first of all, we'll split this one up into two parts, right? And we'll say that this one here, or left-hand side if you like, is equal to the integral from minus a to 0 of function x dx plus the integral from 0 to a of function x dx. Now, we're going to have a look at this one here. So, let's have a look at this one. So, I equals 0 to minus a of function x dx. Now, I'm going to let u equal minus x, right? Therefore, du equals minus dx, or dx equals minus du. Now, what I'm going to do here, right, now this becomes, when x equals 0, u equals 0, but this time this will become positive a, and of course this is function. That means that x equals minus u, and this is going to be equal to times minus du. Right, now the same principle as before, the minus sign will swap these over, so that becomes a naught of function minus u du, which of course means that that's really a naught function minus x dx. And if we replace that now with a naught function minus x dx, then that will be equal to the right hand side. And we've proved that very important property, which we'll do examples of. Okay, here's the first example. We have to evaluate the integral between pi upon 2 and minus pi upon 2 of e dx over 1 plus e dx dx. Now, you could use a log function on this, and if you want to go and do that, you can. It'll work that way. But it's rather nice to see how this little property works. This one. Okay, so we're going to say I is equal to between pi upon 2 and 0 of e dx over 1 plus e dx plus e to the minus x over 1 plus e to the minus x dx, which is pi upon 2 0 e dx over 1 plus e dx plus 1 over e dx over 1 plus 1 over e dx dx, which is pi upon 2 0 e dx over 1 plus e dx plus. Now, this will be e dx plus 1, and these e dx's will cancel. Should have 1 over e dx plus 1 dx. So putting over the common denominator, we get e dx plus 1 over e dx plus 1 dx between pi upon 2 and 0, which is pi upon 2 and 0 of 1 dx, which of course equals x between pi upon 2 and 0, which is pi upon 2. Now, as I said, you can use that log function technique, but it'll be a lot longer than this one. Right, example 2, evaluate the integral of 1 over 1 plus sin x dx between pi upon 4 and minus pi upon 4. Okay, now we can use that property. We go I is equal to the integral between pi upon 4 and 0 of 1 over 1 plus sin x plus 1 over 1 plus sine of minus x dx, and that's going to be pi upon 4 and 0, 1 over 1 plus sine x plus 1 over 1 minus sine x dx, because the sine of minus x is minus sine x. And putting that over a common denominator, you get 1 minus sine x plus 1 plus sine x all over 1 minus sine squared x, which is 2 outside of 1 over cos squared x dx between pi and 4 and 0. This is going to be 2 pi upon 4 naught sec squared x dx, which is 2 tan x pi upon 4 and naught. Now, the tan of pi upon 4 is 1, and 2 times 1 is just 2.